Hey, my name is Gabe with JTech, and today we're going to show you how to calculate resistance in parallel circuits. Alright, so let's get started. Okay, first, for a parallel circuit is not the same as a series circuit. In a series circuit, you'll simply add them. Alright, where's the marker? So in a series circuit, the total resistance is going to be equal to the first resistance plus, can you see that? I can. Plus the second resistance, plus, etc. Okay, so in a series circuit, all the resistance is just simply going to add up. Now, in a parallel circuit, that is not exactly the case. And this marker is open. Okay, so right here we have a just a simple parallel circuit. You got your battery ground over here, and then you have three resistors. You got one with 2 ohms, one with 4 ohms, and one with 6 ohms. Alright, so the way we're going to do this is we're going to use this equation right here. Okay? So you put the 2 ohms in R1, 4 ohms in the R2, then 6 ohms in the R3. Let's go and put that in practice. So 1 over 1 divided by 2 plus 1 divided by 4 plus 1 divided by 6. Alright, and if we calculated that, that would give us our total outcome for the total resistance for that circuit. Let's go and calculate it. Alright, 1 divided by 2. Now what I'm going to do is I'm going to speed up the video so that I can go ahead and get the calculations done, and then you can get the answer quickly. Okay, so I did the calculations, and it comes into a kind of an odd number. Alright, I wasn't using a scientific calculator, I was just using one on the phone. It's a little bit slower, but scientific calculator is a little bit faster. I don't have that handy right now. But the answer comes out to 1.09, and that bar up there, that means it just repeats forever. And then, so it's 1.09 ohms. It's roughly 1.1 ohms, so, we could say it's about 1.1 ohms. Alright, so that parallel circuit with, and I keep this in mind, with 3 or more resistors is going to be 1.1 ohms. That's not for all of them, that's just for one with three resistors that has 2, 4, and 6. Alright, with this diagram. Alright, that formula, my bad. Okay, next I'm going to show you how to calculate it with only 2 resistors. Now it's a lot it's a lot simpler to only calculate it with 2 resistors, because if they're the same number, then you just divide it by 2, and that's what you get. Now, this is going to go away. Alright, so if we're dealing with 2 resistors, we're going to take one away. We're going to take away the 6. Alright, so that leaves us with 2 resistors. We've got 2 ohms and 4 ohms. Now, the formula is resistor 1 times resistor 2 divided by resistor 1 plus resistor 2. Like I said, if they're the same numbers divided by 2, and that's what it's going to get. More often than not, unless you're dealing with the exact same circuit, that is not going to be the case. Alright, so here we're going to have 2, I'll put that in parentheses, it's bad parentheses, times 4, okay, over 2 plus 4. And that is going to give us our resistance for this parallel circuit with 2 resistors. That's only for 2 resistors. That's what this formula is for, just 2. No other number. Okay, so what we got here is going to turn out to be 8 divided by 6. And that's 6 common denominator is 2. So it's going to be 4 over 3. So that's going to be 4/3. Alright, so it's going to be 4/3, but we got to convert that even further. So it's going to be 1.3 bar. So that 3 is going to repeat forever. And yeah, so we're going to 1.3. Let's just go ahead and say maybe 1.4. You could go up to 1.4. It's not much of a difference. Okay, so it's roughly 1.4 ohms. Alright, so that's what the 2 and the 4. That's using this formula. I don't know if you can see that formula. Let's write it a little bit. Hold on. It's blue. It doesn't look like the camera can see it. So it's R1 times, damn it, times R2 over R1 plus R2. That's going to be equal to the total resistance. Alright, so this is the formula that's only for 2. Alright, little disclaimer, I don't have my glasses on my eyes right now because I'm in a classroom. You don't exactly have to have them in the classroom, not much danger. Alright, so hopefully this is helpful. There will be more videos in the future on electrical, so if you want, you can check those out. And thanks for watching.